let us push on because we're almost there, guys. We're almost to the end. Okay, this time I will let you, actually, we should probably work through this because I think you guys are still a little dicey on this. All right, so we have HGOAC. What's the key? What do you think is the key thing here? Mercury. Mercury is your key thing here. When you see mercury and water, this is called an oxymercuration reaction. So we are adding an alcohol, and it is going to go to our more substituted side. That's all that's happening here. So this and this. That's it. We're just adding the alcohol to the more substituted side. The other side gets the hydrogen, but okay. So for our next one, we're adding Br2. So when you add a dihalogen, right, you are simply going to add a halogen to either side of that double bond. The only thing you need to remember is that they are going to be in opposite directions. So one is going to be a dash, the other will be a wedge. So then that means you're going to get a second one. Where now this is going to be the methyl like this. This bromine will be on a wedge. This one will be on a dash. Oh, this should be a bromine. Sorry. Like that. Okay, H3O plus, what are we doing here?
It's the same as the first one.
Yes, what's the difference? We don't see it happening here. As I attempt to draw a 5-numbered ring, but apparently I can't. We're gonna have, again, we're just gonna have this and then this in the OH. Do you guys know what the difference is? Okay, so we're gonna take a small pause here because I think this is something that might be relevant to you. We're gonna go back to the whiteboard. All right, so I just have to think about how to draw this real quick. Okay, so imagine this is my reagent here. And I did H3O plus. I want you guys to predict what my product is going to be. I'll give you 30 seconds to think about what the product is going to be. Okay, here's what the product is going to be for this reaction. Why is that?
Because it gets added to the more substituted side.
Well, the more substituted side is here, which is this one. Is that OH added to a carbon that's part of the double bond? Nope, because when you do H3O plus, you form a carbocation intermediate. So you can have a rearrangement with this. Rearrangements are possible. Now, if I do this reaction, but this time I do it with the mercury oxymercuration, so the Hg I think it's OAC2 and water and sodium borohydride like this. What do you think my product is going to be now? This time, I don't form a carbocation intermediate, so my OH goes to the more substituted side like that. If I want my OH to go to the more substituted carbon and I don't want to risk any type of shifting, I use the oxymercuration, right? If I wanted my alcohol to go to the outside, like this, that's when I would do the BH3 nonsense one, the hydroboration. Okay, so these two here are ones that do not have shifts happening. They will give you just one type of product. There's no worries because you don't form carbocations. When you do H3O plus, you run the risk of that happening. Does that make sense? Am I overloading your brains right now? Are you reaching peak overload for one night? It's okay if you get there.
I'm getting there.
Okay. But this is just what you need to keep in mind for these. So it's the best I can give you. All right, so let's go back and we're almost done for the night. Gwen, you can make it. Okay, now what is going to take this ring and form this? So anytime you see a double bond disappear and it, what looks like happened to our double bond? We essentially
separated the ring.
We essentially cut it, right?
Yeah.
This is O3, ozone. This is ozonolysis.
Would you have to add DMS to it?
Yeah, so DMS is going to give you the aldehyde. If you had H2O2, that gives you the carboxylic acid instead. All right, and for our last one, CH3CO3H plus H3O plus, what are we forming here?
You add 2 hydrogens and in addition to where like the double bond is.
You're going to add 2 alcohols.
Yeah.
The only difference is that now, what was the stereo? Last time when we did these alcohol reactions, did we add them the same direction or opposite direction?
For this one, it's the same, right?
No, these are different. The last 2 we did, remember the other ones we did on the other page? Those were the same. This one, these are anti. Oh. So OH on a dash, OH on a wedge, and it doesn't matter which one you do. They're just going to add differently. So when you do the CH3CO3H followed by H3O plus, you're adding diols to alcohols, but now they're going to be opposite directions. Questions?
For this one, would it also be the opposite way as well, or just?
Yep.
Okay.
So you could get this and the enantiomer of this one. Other questions? All right. Okay, provide an IUPAC name or structure from the IUPAC name for the following, and then where are we going with this? Let's get past the IUPAC names for right now. We can work on these a little bit later because I think you guys are pretty okay with IUPAC names, right? Real quick, what are the things you need to watch out for? And your professor even gave you in the description of the problem.
Chiral centers.
You need to watch out for chiral centers. So how many chiral centers do you have in your first one?
2.
You have 2. What's your key indicator that something might be a chiral center? If you see a dash or a wedge emerging from it. So you see a dash emerging from this carbon, that is a chiral center. You see a wedge emerging from this carbon. So these are your 2 stereocenters. That's usually a good indicator that you have a stereocenter somewhere. That's not always true, but that's usually your good indicator, all right? We'll come back to those. All right, so answer the 5 following multiple choice questions. Circle all that are true. Which reactions has a rate that depends on the concentration of the substrate? Which one has a rate that depends on the concentration of the substrate? Think about that.
Is it SN1 and SN2?
Okay, you say SN1 and SN2. Right. Anyone have any other thoughts on that?
E1 and E2 maybe.
E1 and E2. Okay. So we have SN1 and SN2, and then we have E1 and E2. Any other?
I agree with SN1 and SN2.
Okay, so you agree with SN1 and SN2. Mags, do you care to weigh in on this?
I think it's the SN1. You're good. I think it's the SN1.
It's all 4 of them.
Oh. Well, I thought the E1 there were like bases, but I guess
SN1 depends on the concentration of the substrate by itself. SN2 depends on the concentration of the substrate and the nucleophile. E1 depends on just the concentration of the substrate. E2 depends on the concentration of the substrate and the base. So the reason why E1 and SN1 only depend on the substrate is because what's our rate determining step? It's when the leaving group leaves, right? So it just depends on how many substrates you have there because the leaving group pops off of that. All right, so E1 and SN1 are just dependent on the substrate. SN2 and E2, the nucleophile attacks the SN2 or attacks the substrate, or the base will remove the proton. So that's why those ones require it. But the concentration of the substrate, if you change the concentration of the substrate for any of these reactions, you will change the rate. If I change the concentration of a nucleophile, I only impact the rate of SN2. I will not impact the rate of SN1, and the same thing with base. Does that make sense? Okay. Let's go ahead and go to the next one. Which of the following is a tertiary alkyl halide? What's my recommendation to you guys?
Draw it.
Draw it out if you don't know. So my answer should be 4. Let me know if you see that. Melissa, you good? Okay. How about you, Gwen? Are you just saying that? Okay. Mags, how you doing?
I'm doing good.
Okay. C, addition reactions of alkenes are characterized by blank, formation of a pi bond, addition of two groups across a double bond, breaking of a pi bond, 1 and 2, or 2 and 3.
I'm gonna go with the last option.
Okay, you're going to say 2 and 3.
Mhm.
That's correct. When we do an addition reaction, we are adding across a double bond, and in that process, we break the pi bond. Okay, so that should be 2 and 3. I could go for a pi. Okay, describe the regioselectivity and stereospecificity in the hydrohalogenation of an alkene. So hydrohalogenation, its regioselectivity should be the easy one. So what is the more common type of regioselectivity? Markovnikov or anti?
Is it anti?
Anti?
Markovnikov. Markovnikov is the much more common one. What are some of our, do you guys remember what some of our anti-Markovnikov ones are? We talked about one earlier when we added an alcohol. Hydroboration, that's an anti-Markovnikov one. That's the one where we have BH3, right? With NaOH, oh, sorry, THF. And then we have the NaOH and H2O2, right? This is one of our common ones. The other one is when we add an HX with a peroxide. This is one of our other anti-Markovnikov ones. By and large, most of our reactions are Markovnikov in nature. Does that make sense? So hydrohalogenation is Markovnikov. Now, when we do a hydrohalogenation, is it anti-addition, syn-addition, or is it both?
Can it be both?
It's both. What's the clue that it's both? So I'm gonna draw you an example. So if we did this, I want you to think about the mechanism and why we're gonna get both syn and anti-addition. When you come up with an answer in your head, let me know. There's something that occurs in the mechanism that should be a dead giveaway. As I'm still trying to finish my dinner from earlier. I'm sorry. When you use a carbocation, when you form a carbocation, you lose stereospecificity. This goes away. Whenever you form a carbocation in a mechanism, that stereospecificity goes away. So a stereospecific reaction would give you like they're both on wedges or one's on a wedge, one's on a dash kind of thing. The second you form a carbocation in a reaction like this as an intermediate, you're going to get both. There's no longer any stereospecificity. That's the clue that you keep in mind. So if you want to make a note for that. The second you have a carbocation in a mechanism, you lose any stereospecificity. It just becomes syn and anti. Make sense? Questions on that one? Confused? I can explain in more colorful pictures, or you can just write that down as a fact. I'll leave that up to you in your mindset. Okay, let's try and name this last one. provide the UPAC name for this beast of a thing. Let me know when you guys come up with an answer. So this is something that I do when I want to name something. If I draw the line structure. Sometimes that's a little bit easier for me to see than just having that thing there. So I draw out what they gave me into a line structure, and sometimes that makes it. So I'm gonna, you know what, you guys need help. You guys need help passing this test. I'm not gonna dick around. What's the one thing that you can do to help make your life a little bit easier right off the bat to eliminate some answers? Is there any answer that you can get rid of straight away?
The first
Or
one.
5.
You can get rid of the fifth one because remember TERT, ISO, and all of those weird things, those are not IUPAC names. So if you see anything like TERT or ISO in a name, immediately gone. Next thing you want to do is try and number from left to right. 1, 2, 3, 4, 5, 6, 7. And then do it the other way. 1, 2, 3, 4, 5, 6, 7. What is your biggest functional group in this molecule?
The triple bond?
The triple bond. And that needs to start on the highest number or the lowest number?
The lowest number.
So what should the number be that it starts with?
3.
3.
3. So I can get rid of 2 because it cannot start on 2. There's no way that it can start on 2. 4 would be going the wrong direction. So now I have eliminated everything. And so one of these answers should just make sense.
Number 4.
Number 4. Yep. Does that make sense on how to work your way through those a little bit quicker? So draw the line structure. That's the first thing I recommend because sometimes it's a little bit easier to see that. The next thing, look at your answers and cross out any of them that have TERT, ISIL, or anything like that. The next thing you want to do is find your biggest functional group and figure out what number is that going to be. Is that going to be a 2, a 3, or 4, or 5, whatever the problem has. Once you figure out what it needs to be, then you can eliminate, and usually you can make a pretty good guess at this point, right? Or you can actually name it step by step. But at this point, if you're getting to this part of the test, it might just be a time game, right? So you might be running out of time. Okay. You guys look a little dejected and a little beaten. I think that's because we threw a lot of information at you. That is fine, right? This is the first one we did where we walked through every problem. Tomorrow, we're going to do the last practice exam, okay? So tomorrow should be better. You guys are going to have a little bit more. You'll see things repeating again. Practice, practice, practice. On Thursday, I think I have a practice exam that I gave at some point that I can share with you guys. That way you can do it, and it has the answers on it. So then that way you guys have practice problems you can do, and we can do those on Thursday along with any other things you want to ask last minute. So we will meet tomorrow. We will meet Thursday. You guys are picking it up. I know it's a lot of information, but just keep at it. Like Melissa has, use your notes, make your notes properly, set them up accordingly, right? So what I would do is that if you have your notes like that, at the very top of your note, if you use a note card, write what it is, like stereospecificity of reactions, regioselectivity of reactions, SN2 requirements, SN1 requirements, things like that, right? You want to make your notes pop so you know where to look if you have open notes. That's really the key to passing an open note exam, is knowing where you're looking. Like if you know what you're looking for and you have them labeled properly in your notes, that makes your life so much easier, right? This is the time that if you're very anal retentive about making notes, this is your time to shine. So what I would recommend though is that you guys do try and get some sleep. I know that's easier said than done. I tell my high school kids this all the time. And again, it's easier said than done, but try to get some rest. Obviously you have to study, but sleep is important. Food's important. Getting sunshine is important too. I don't know what is the weather like in Flagstaff right now? Is it still cold?
It's finally got warm.
Yeah, it's really nice. I went outside today and it was like perfect. It's like 60.
Yeah.